Okay, plug 216. Last of all the ACT worksheets, definitely not the least. In fact, uh, 215 and 216 are two concepts, draw on the scale and plug, are two concepts that you will not be taught in school, concepts you won't use on the GCSEs or A levels, but concepts that are extremely helpful on both SAT and ACT exams. So they're concepts that may feel a little alien and unfamiliar, but they're very logical and they enable you to solve problems in kind of lateral, outside the box ways. They show you different ways you can think about problems and still get them right, even if you're stuck on kind of the linear, straightforward path. So, with no further ado, let me kind of explain how both plugging numbers in when you match expressions and how trial and error with answer choices works on this exam. And what you'll ultimately see is that out of 60 problems, the methods you'll see on this packet, you probably use it for about 10 on the exam. So these methods are extremely relevant, more relevant than any other skill that you'll develop through these other worksheets because of the fact that these skills are not specific to any singular type of problem. So let me show you what I mean. So if we look at this first example, I know it's quite obvious that if you're trying to figure out, well, this should actually be the expression, but if you're trying to figure out what expression this is equivalent to, you know, because of distributive property, that this is B plus AC. And I know that's blatantly obvious, but let me show the method on a problem that is blatantly obvious, and then I'm going to show you one that's much less obvious. So I avoid using 0 because that turns everything to 0. 1 is also not a great number. You won't ever get the wrong answer. You just may get multiple matches, and then you'd have to change numbers anyway. I know that probably doesn't make sense right now, but everything will make plenty of sense in just a moment. So I'm just going to make A2, I'm going to make B3, and I'm going to make C4. My logic is that if I put in these inputs into this expression, whatever output I get, if I put in these same inputs into the answer choices, then the correct expression, the equivalent expression, should match the output I originally got. If they're the same expression, the same inputs should yield the same output. So if we apply this, we have 3 plus 4, which is 7, times 2, and that gets us an output of 14. So with these inputs in this expression, we get an output of 14. Well, ABC is just 2 times 3 times 4. Well, that gets us 24. That doesn't match our output because it's not the right expression. If we look at this one, A times B is 6 divided by A times C is 8. Well, 3/4 certainly doesn't match what we're trying to get. But if we look at answer choice B, A times B is 6, A times C is 8, and sure enough, we get an output of 14. So I know that feels like, why would I ever do that when I just know that this and this are equivalent? That took a long time, and it was a lot of guess and check. Believe it or not, if you're quick just to kind of set up the inputs and figure out the output and then just go right into the answer choices, if you do this packet and get enough practice, it will take less than a minute most times. And a lot of times it will actually be easier than the alternative, which may take longer, or even worse, lead you down a dead end where you're stuck. Case in point is this problem. This is an SAT problem, but it's probably the best problem I have to make this point. Take as long as you want and see if you can figure this problem out. Feel free to pause the video, take as long as you want. If you're stuck, I've outlined all the steps below, so you can try that. But I'm just going to do this plugging, and we'll see how long it takes. You can put me on the clock if you want. So it wants to know which of the following expressions represents y in terms of x and r. So essentially, it wants us to isolate y. But I am just going to plug numbers because it's the ACT and I have a calculator. I mean, I could try to isolate y. And again, I'm warning you, it takes a lot of steps. But I'm just going to make x equal 2. I'm going to make y equal 3. So what we have is we have 1 over 1/2 plus 1/3. And that's going to dictate what r is in just a moment. So really, we have 1 over, this is 3/6, this is 2/6, so we have 1 over 5/6. So really, r is going to have to equal 6/5. So what we figured out is that when we pick 2 and 3 as inputs, our output is 6/5, and that's what allows us to balance this equation. Now we just have to find a match. So we have to figure out which one of these expressions right here is going to equal y, which is 3. Well, r is 6/5 minus x, which is 2, so that would be 12/5. That's going to get us a negative number. So we already know that that one's gone. If we look at b, we have 2 times 6/5, so that gets us 12/5. And we have that over what I'm going to call 10/5, right? Because that's 2, 10/5 minus 6/5. And that gets us 4/5. So what we effectively have is 12/5 over 4/5. Well, 12/5, I'll do it in black. 12/5 times 5/5, because if you divide by a fraction, you multiply by the reciprocal, that's going to get us 3. So we've gotten our match. We would check the other answers, but I won't bother now for the sake of time. But you would quickly check the other ones, make sure that none of those match the 3 that we were looking for. And if this is the only one that matches, then you're done with the problem. You've figured out that these inputs balance this equation with this output, and then you've just used the same inputs and outputs, and you've determined which equation balances with those. So you know that this is equivalent to this. And again, 12 steps to do that algebraically. So you can look at that later if you're interested. So anyway, I've picked some of the hardest problems, like the last 10 problems from different tests, and you can try these on your own. Feel free to try any one of these problems on your own, but you're going to see how much easier these are when we do them plugging. So here's 16. Feel free to pause the video. I'm just going to kind of go ahead. If A is 25% of B, then 135% of B is what percent of A? Okay. So I think it's easiest just to determine that B is 100. We're doing a percent problem. So if A is 25% of B, A is 25. 135% of B is what percent of A? Well, 135% of B, our output, is 135. And we're going to determine what percent is that of A. 135 divided by 25. We get 5.4, so 540%. That easy. And yes, you probably know how to do it alternatively, but if you didn't, that's an easier way or another way to do it. Okay, let's look at this problem. For all real numbers A, B, and C, such that A is greater than B and C is less than 0, which of the following inequalities must be true? Okay, I'm going to make A 3, B 2. We'll make C negative 2. Okay, so the way we're going to treat this is we're going to run through these, and we're going to run through all of them because we have to double check. If 2 work, we can think about it or we can change the numbers. You could even look at this and kind of think through it logically and see what you can get to. But with numbers, we can kind of quickly get rid of anything that can't work. So you can pause and just try to think through this. But we're just going to run through it fast with numbers. So we have that 3 over negative 2 is less than 2 over negative 2. And that's absolutely true. Negative 1/2 is less than negative 1. So our answer should be A, but let's quickly run through these other ones. So this one's just opposite. It flips what we just had. So we know that that's not true. A times C, so 3 times negative 2, so that's negative 6, is greater than B times C, which is negative 4. Well, we know that that is not true. A plus C, so 3 plus negative 2, which is going to be 1, is less than 2 plus negative 2, which is 0. So that's not true. A is less than B minus C. So A is 3, b minus c is going to be 2 minus negative 2. So 3 is less than 4. So interestingly, we have two answers that seem to work here. So the question is, well, what do we do from here? So we can kind of pause and think for a second, or we can try to throw in some different numbers and play around with things. Logically, I'll kind of explain why it's not going to be E. Let's pretend that A is much greater than B. I'm going to make A 10. Well, in that case, if we look at this problem again, ten is not less than 4. Okay. But if we go back to this problem, making A 10, negative 5 is definitely less than negative 1. So A is our ultimate right answer. Okay. Got two more problems of this concept, and then I'll show you the next concept. Actually, I'm gonna just go to one of them. Let's do 29. 29 gets a lot of people. Again, feel free to try this on your own. I'm just going to go forward and plug numbers here. So they have this expression and they want to know which one it's equivalent to. Well, I'm just going to make, I'll make R4. I'll make S equal 2. So what we have here is we have the square root of 2, right? Because 4 divided by 2 is 2, plus square root of a half. So we'll put that in our calculator. And we get 2.12 about. So when we use these inputs, our output is 2.12, roughly. So that's not 1. And let's take a look. The square root of 8 times 2. So square root of 8 times 2 gets us about 5.65. Divided by 6, well, that's going to be less than 1, so it can't be that. 2 times the square root of RS, well, the square root of 8 times 2, that's likely going to be much more than 2. Let's see. Square root of 8 times 2. That's going to get us 5.65. Oh, well, we just did that there, right? That's just the top of that one. I should have realized that. So that's way too high. R plus S divided by RS. Well, R plus S is 6 divided by 8. That's 3/4. That's not 2.12. So finally, we have 6 divided by the square root of 8, which is, we said, was about 5.65. So 6 divided by 5.65. Well, that's not going to match our output as well. So I definitely screwed something up here, which doesn't bode well for your confidence in this strategy. I completely understand. But let's kind of go back and take a look at everything. And then I will do this one algebraically, by the way. I promise I'll do that as well. So we made R equal 2. Or actually, we made R equal 4, didn't we? We made R equal 4. We made S equal 2. And what we got is the square root of 2, right? Yes. And then the square root of 1/2. Add those together just to double check again. 2 square root of 0.5 plus 4.142. So our output should be about 2.121 again. And let's just roll through these again real fast. So it's not 1, given these numbers. This is 8, square root of 8 times 2. 5.65 again. Divided by 6, that's definitely not going to be the correct answer. 5.65 times 2 is going to be way too high. R plus S is going to be 6 divided by 8. That's 3/4. So that's not correct. And then 6. Huh. Let me get the right answer algebraically, and then I'll look back at the plug. So root R over root S plus root S over root R. Okay. So looking at this right here, what we would do is we need a common denominator if we're doing this algebraically. So we're going to multiply this by root R over root R, and this by root S over root S. So what we get here is we get R over the square root of RS plus S over the square root of RS. And that gets us R plus S over square root RS. So we know E should be the right answer. The question is, why did that not work when we plugged? Again, just looking at this real quickly, if we make R equal 4 and S equal 2, this is going to be the square root of 2. This is going to be plus the square root of a half. And when we go second square root 2, about 1.414, square root of a half, .707 roughly. Add those together, and you're going to get just a little bit over 2. Right, approximately 2.12. So if we go back into this one, it really should work. 4 plus 2 is 6 over, let me reevaluate the square root of RS, second root 8. Oh, I'm being really silly. The square root of RS is 2.82. I really apologize here. 6 divided by 2.82. And there we go. We get about 2.12. So I really apologize for that. I probably wasted about 5 minutes of your time. But just to clarify, if you plug in numbers and you actually are careful with how you're doing it, you will get a match on this one. Okay. Let me show you this last idea. This idea of just being able to kind of enter answer choices. So for 37, it says, this is just trial and error with answer choices. So this says, for what real value of x is this equivalent to 1/9? So I'll show you how to do it logically in a second, but the easiest thing to do is just to plug these options into your calculator until you get it to work. I'm going to kind of spoil the ending here. It's going to be D. We have 3 to the 14th times 3 to the 4th over 3 to the 20th. And if you put it in your calculator, you'll get 1/9. If you want to see how this works algebraically, well, 3 to the 18th, 3 to the 20th, you're going to end up with 1 over 3 squared when you simplify, which is 1/9. But yeah, for this one, just easiest to just trial and error with the answer choices till you get it to work. One more. So this one says points 0, 0 and 0, 3 below lie in the standard xy coordinate plane. The collection of all points such that each is twice as far from B as it is from O. So everything's twice as far on the circle from B as it is from O forms a circle. And then this point is 1 point on the circle. What coordinates are the center of the circle? Well, let me zoom out for a second. Just using logic right here. Like if we just try to complete this circle, what do you think the center is? Do you think the center is below 0, 0? I think not. Do you think the center is all the way down here at -3 of this circle? I think not. So really, just by common sense, the answer is D. But if you want to check this, if every point is twice as far from B as it is from O, then just like we have √3 here, and then this dotted line would be 2√3, you could also draw to this point, and you would have a √3 and a 2√3. So that would be another point on your circle. And if we just draw out our circle here, you'll see that it very much looks like that is your center. And to double check, well, is 0, -1, is that twice as far from B as it is, or sorry, you could take, it's more complicated than what it's worth. I'm thinking about it, but it's more complicated than what it's worth. Hopefully it becomes very obvious and apparent that D is your right answer for this one, just by kind of using logic and understanding that the figure is drawn to scale. Okay, anyway, good luck with this. I strongly recommend putting in the time on this worksheet. I think that either it will become a major strategy for you or it could become a backup strategy for you on the test. Either way, it should help you get some more problems right on the math section. Okay, well, good luck.